We have a couple of people waiting already. Right. Going live. Wee. Alright, I'm not entirely sure what the delay is on this. So if you guys could let me know if you're here. And you guys can sit and watch me try to explain the solubility equilibrium expression again. And hopefully it makes more sense this time than earlier. Sorry for the late start again. I had some technical difficulties that I did not fully expect. So hopefully it works out well for you. Or hopefully it works better this time. Let me know if you guys can hear me clearly. If not, I'll have to adjust some of my voice settings, maybe? I don't know. Alright, let's see. It is now 8:30. Not entirely sure what the I'm not sure what the delay is. So if you guys do have any questions, feel free to ask. Okay. I attempted to do this earlier, but nobody was watching, and I had some massive issues with the microphone, so it didn't sound very good. Hopefully it sounds better this time, and you guys can hear me quite clearly. Okay. Sorry. Anyways, so to start with, I'm going to go back to talking about how we calculate KEQ as the concentration of products over reactants. So this was something we talked about in the last unit. And from the last unit, we described that the concentration of products, so if I had a sample reaction like this, A plus B going to C plus D, the concentration of products would be concentration of C times concentration of D, all divided by concentration of A and concentration of B, right? So this was kind of what we did in the last unit, and this seemed to be okay. Nobody's gonna have any issues with this. And if we had a situation where we had, let's say, where we had something like 2D, nobody seemed to have any issues by just adding this in here and then simplifying this to C times D squared. So that's just how equilibrium works. This is the experimental evidence showed us that this is what happens. Okay, but I think it bothered Connor a bit when we were going through this the first time. But again, experimental evidence showed that I guess I'll highlight it in a different color. This portion here is how we deal with a case where we have multiple products like this. Okay, and we can expand this even further. So if I had a reaction where I had A plus B creating something like C plus 4D, I think either one of your test questions or one of your assignment questions had something like this. Well, the KEQ equation just ends up being concentration of C times concentration of D times concentration of D times concentration of D, like this. But we always just end up simplifying that to just D to the 4th power. Okay, so this ends up just being C. And this ends up being D to the 4th power all over top of A and B. And this, again, nobody seemed to really have anything to say about it when we discussed it in class at that time. So I'm not entirely sure what caused the issue with this one, but probably because the equilibriums we're dealing with are actually a little simpler than what we were doing last unit. Because in this unit, the equilibriums we dealt with, we ignore the reactants and we just end up with whatever the products are. Okay, now once again, I have to say that this equilibrium expression here, okay, is experimentally determined, and this number here is determined by this equation that we have here. And this equation depends on, if I have multiple products, I have to count the concentration of each product, or I guess each reactant. If I have multiple reactants, I have to count the concentration for each time that particular product shows up. So this is why the concentration ends up being d to the 4. Okay. Now, in last unit, when we were discussing ice tables, yes or no ice tables, a lot of you guys kind of had issues with setting that up, but let's talk about them again. If I had an ice table set up for something like this, most of you were able to figure out that whatever the equilibrium concentration was, so if I had, let me just set this up quickly. So if I had an ice table for this, okay, and I had some amount of this, and none of this, most of you were able to understand that if my reaction goes forward, I'm going to lose some amount, I'm going to lose some amount, I'm going to gain some amount, and because I have 4 of these, I'm going to gain 4 times that. So this was actually quite good that most of you guys understood this. Okay, most of you guys understood this, and then it was easy to transfer this concept back to the equilibrium expression, which was concentration of C times concentration of D to the 4th, all over top of A and B, like this. And most of you were able to say, okay, well, this is the concentration of D, so let's put the concentration of D into here, and this happens to be 4th. So whatever the concentration of D is, we take it to the 4th power. And again, that's because the equilibrium expression is based on the number of times that this product shows up in the product side of the reaction. If it appears 4 times, we have to multiply it in 4 times like that. But the concentration of D is actually this. So this is the numerical value of the concentration, and the reason we have it here as to the power of 4 is because it appears 4 times. Okay, and I guess that's kind of where the confusion arises, is that a lot of, well, the people who are making a fuss over this, and I can see where they come from, because it was actually asked on Google a few times when I looked earlier today, is that if I already have the 4 taken into account here, why do I have to take it to the power of 4 again? Because this 4 here refers to the concentration, whereas this 4 here refers to the number of times that it shows up on the product side. Okay, as part of setting up the equilibrium expression, remember that the equilibrium expression is set up, this is a simplified version, is set up as the concentration of all the products. Okay, so if that product, or the product of the concentration of the products, and then they get added in like this, right? So each of these concentrations, because we know D has a concentration of 4y in this case, each of these concentrations is going to be 4y. And the reason it's put in 4 times is because it shows up 4 times in the product side of the reaction. So hopefully that makes sense. And this was actually, I think this is similar to how somebody explained, one of the students in the class explained it to me this way, and upon looking further into it, this is kind of how you should see it. Okay, now if that doesn't satisfy you, I can at the very least give you a reason as to why the concentration of D has to be 4y, or I guess in this example, why it has to be that way. Okay, I'll start with this. I'll go back. Okay, actually I'll use a simpler example. Okay, so here we go. So at least after this, hopefully you'll be able to understand at the very least why the concentration needs to be at least, in this case it'll be 2x, but hopefully you get the right idea. So going back to Chem 11, if I had 1 mole of this, we know that this will dissolve into the following. Based on this mole ratio, if I have 1 mole of AB2, this will dissolve into 1 mole of A. And then it'll dissolve into 2 moles of B, like this. So so this equation here describes the mole ratios. So if I know how much moles I have of something, it'll dissolve or separate into this. Okay. Now, let's suppose I have this for simplicity's sake. I'll throw this into a 1 liter container. Okay. Then the concentrations will be as follows. The concentration of A will be 1 mole per liter, which is going to be 1 molar. And then the concentration of B will simply be how many moles of B I have over 1 liter. Now, so at the very least, now you know why the concentration ends up doubling. Okay, it's using mole amounts. Okay, now in our equilibrium, so let's see if hopefully I can have enough room here for this. If this was an equilibrium, so if this was an equilibrium like this, the equilibrium expression would be written as follows. KEQ equals concentration of products, and I'll write it as this because, again, the equilibrium expression, we put in the product the number of times it appears in the actual reaction. So this appears twice in the reaction, so we put it in twice in my equilibrium expression. Okay, and then concentration of AB2 like this, but this is a solid, so this doesn't actually matter because it's a solid. So the equilibrium expression will then simplify to as follows. KEQ equals concentration of A times concentration of B squared. But what is B squared? B squared happens to be 2 molar. So that's the concentration of B is 2 molar. So this will be 2 molar squared. Concentration of A is 1 molar, and there we go. Okay, now you could hopefully be able to see that if I just replace the 2 molar with 2x, so let's use a different color. So let's say if I have unknown amounts, then I can just put unknown amounts there, then this becomes 1x and this becomes 2x. And now you can see, I hope that you can see that this is why the concentration of B is 2x and why it ends up being squared. Okay, so it's not quite how you would have, I guess, how it kind of makes sense the way some of you were thinking about it, but it's not actually correct that way because I think that comes from the misunderstanding of how to set up this equilibrium to begin with. Okay. Alright, so hopefully that makes more sense. So hopefully that makes more sense. If it doesn't make any sense, or if it still doesn't make any sense, then you can come by my class and you guys can ask me questions, because that's what you should do if things don't make sense. Alright. Okay, if you have any questions or comments right now, do put them in the chat. Okay. If you have any questions you want me to go over from your textbook, I'll be on for a little bit, and it's only what, according to my clock, it is 8:42. So if you guys want to ask me questions, yeah, do feel free to type it out in the chat. And again, if this explanation doesn't quite make sense still, yeah, come find me and maybe we can work it out. Okay. Okay. And the reason it's put in 4 times is because it shows up 4 times in the product side of the reaction. So hopefully that makes sense. And this is actually, I think this is similar to how somebody explained, one of the students in the class explained it to me this way, and upon looking further into it, this is kind of how you should see it. Okay, now if that doesn't satisfy you, I can at the very least give you a reason as to why the concentration of D has to be 4y, or I guess in this example why it has to be that way. Okay, I'll start with this. I'll go back. Okay, actually I'll use a simpler example. Okay, so here we go. So at least after this, hopefully you'll be able to understand at the very least why the concentration needs to be at least, in this case it'll be 2x, but hopefully you get the right idea. So going back to Chem11, if I had 1 mole of this, we know that this will dissolve. Okay, if you guys don't have any questions, based on this mole ratio, I suppose I have 1 mole of stop in a few minutes, unless somebody types something in quickly. The concentration needs to be at least, in this case it'll be, yeah. So going back to Chem11, if I had 1, that this will products. All right, so hopefully that makes sense still. Yeah, come find me and maybe we can. So hopefully that makes sense. Yeah, come find me. Nope. Okay. Man, I gave them an opportunity. Few minutes, unless somebody types something too quickly. The concentration needs to be at least, in this case it'll be, yeah. So going back to Chem11, if I had 1, that this will products. All right, so hopefully that makes sense. Man, I gave them an opportunity. Few minutes, unless somebody types something too quickly. The concentration needs to be at least, in this case it'll be, yeah. So going back to Chem11, if I had 1, that this okay. I have to remember to remove my desktop audio. It's really strange hearing myself talk like that again. Alright, well, you guys really don't have any questions from your previous assignments? Well, you're welcome, Ishan. Hopefully, it helps. Anyways, I'm nearing almost 20 minutes of being live. It's rather interesting, kind of fun. I really wish more of you guys asked questions. I've been a lot nicer. Oh well, that's okay. Alright, see you everybody in class tomorrow. And again, if you have any questions, don't forget to ask, and watch my other video on how to use KSP to predict precipitate formation. Alright, have a good night and try to get some good night's sleep.